Hey, good morning. How's everybody doing? I'm Rob, around here that I'm called the Developer Dad, and it is Friday, October 25th. We are in the depths of spooky season. I'm going to see if I can get my USB camera to behave itself again. Aha! Yes, good. Now I can turn my robot back on, and it'll follow me around the room. It's currently plugged in, and the power cable's a little bit stretched, so it's dancing around on the box I have it sitting on behind my laptop. All right, and let's see about GitHub Copilot, shall we? Go to Copilot settings. Copilot in your IDE. Okay, good. I think I've got it. Copilot chat in the IDE. Yeah. Improvements, yeah. And I am using it as me. On my personal profile. Yeah. So, let's see. Status ready. Let's open the completions panel. There's that. And can I put it somewhere else? I guess not. I'm not that worried. And am I sharing my screen? I am. All right, so we've got our basic rule here, right? And let's take a look at the test app console and see what all in the test app types. Sorry, I want to look at sample rule. Now, rule function name is the rule name. All right, so this is for hard-coded rules, and we can see that sample type.name equals Bob. Target property is sample type.name. This rule applies to sample type and uses a property of string. So, what if we wanted to make something a little bit more flexible? See, these generic type constraints are going to cause us problems when we try to serialize them or build a collection of rules that apply to different type things. So we need to wrap these in a way that allows us to set things up more generically. Let's crack into Copilot chat. I looked yesterday, and I noticed that Copilot Chat is $10 a month, and I realized that I have a subscription to something else that I'm no longer using that costs $10 a month. So I canceled that and signed up for this, at least for a month or so, to see how well it works. I would like a way to build a rule from configuration data at runtime and store it in a dictionary the dictionary cannot use typed generics as the type arguments will differ from one rule in a rule set to another. Create a factory method that builds rules from configuration data at runtime, stores them in a dictionary using the non-generic base. And then I'm thinking that it'll instantiate these configurable rules Okay. So let's take a look at what this is doing in deeper detail. So I've got my sample rule here. And it needs iRule bool evaluate object target. Okay. Target is sample type sample, sample.name equals base value. So there's that. Factory method. String rule name, target property, base value, operator kind. Now we need additional information on that target property. So let's try this. We're going to need an interface. That's plain as the nose on my face. And thinking. So instead of rule base with a sample type and string, because that's a neat idea. we go to rule base, I want to go to the definition of rule base. Function name, target property. Type of V is the type of value that we're expecting. Rule applies to is type of T. And this is a system func base. I want to go to the definition of that. Public abstract U, execute T subject. All right. See, we can't get away from this generic stuff without downcasting to object. And that gets really, really goofy. That gets exceptionally goofy. I need to add some comments on this. Provides the format for T, defines the type of the object that the object instance that the function will operate upon. Defines the value, the type of instance that the function will return. Save. Now see, we need something on system func base that allows us to call execute on that base class, but have it operate on something. And the system func base go here. This doesn't inherit from system func base. However, is equal operator. Go to definition. Inherits from operator base, which is just raw thing, and it has func object bool. And register known type strategies. Okay. All right. That runs evaluate. On T. Okay. Here's our equal operator. Rule expression. Bases. So we pass the operator kind. Evaluate happens against a compiler-defined type, or either coding time or compile time derived type. So here's our rule expression. And all this really does is wrap this. And so when we ask for an equals rule, we're getting the rule expression and providing it. So we could create some factory methods on rule expression. Rule base. I don't know that this necessarily, well, it does kind of need to be a base class. But what if we make it so that it doesn't have to be abstract? And I don't think we need it to be a system function base. And we'll pop this up on this line. Save. Now, there's a complaint down here somewhere. What's it complaining about? Let's just build. What's sample rule complaining about? Okay, now this is a typed rule that could be built into a library. Now, and we'll seal that one. We don't want to inherit from that any further. But we do want to keep rule base as available to us. What's this? I don't know why that's still complaining. Let's just build. Rebuild the whole darn thing and see what the problem is, because I'm not seeing it in the IDE. TDD framework, yeah. Object does not contain a constructor that takes one arguments. So where's that coming from? Oh, that's right. It no longer inherits. There. See you later. Save it, and let's try running the test app console. Debug, stat, oh, it wants DevTools access. Yeah. Why are you being silly? All right, so we've got Bob sample. We'll just step over that. New sample rule. We'll execute. What was the result of that? So that's false. We'll execute that. That's true. And we're all done. Cool. All right. So, can we now I want to create a rule instance without knowing the types of the subject or subject property in advance. So we need a rule definition. And all it's going to be is a data object. So we're going to add a class called RuleDefinition. Now, to help Copilot, defines the properties that are used by a rule builder to create a rule. These properties will be primitive types, must be, all right, so prop string rule name, prop string subject type name, prop string property type name, prop string operator kind name, prop object comparison constant. Okay, these are the ingredients for building a rule. Save that. And yeah, it's complaining about all of this stuff. Equals string.empty. We'll just inline initialize these properties. Comparison constant is string.empty. There. Completely empty thing. But cool, we got it. So let's come out to Program CS. Save this. I want to close everything else. Goodbye. First, we'll define the rule. Now, this part shows how to use typed rule that has been constructed explicitly in code. This is the easiest but least flexible way to do this. But least variable way. In cases where we need something special to happen in a rule, we can fall back to this method for logic that can't be expressed as serializable data. Okay. Rule definition. My rule def equals new. Now, it doesn't know anything about this stuff, I wonder if I open up rule definition. Where are you? Here we are. Bring that into Copilot's context here. Where are you? And I'll also open up sample type. Okay. Can you see the 3 class files I have open in the editor? Okay, whatever. I'll just use IntelliSense. Okay, so we have rule name, excuse me, equals my sample rule. Subject type name, test app types, property type name, and I want to do this. Name of sample type. And I'm going to say sample type dot name dot get type dot name. Operation kind. We'll just do operator kind dot equal dot toString. Comparison constant equals Tom. Now, I didn't like that. How about operator kinds? There we go. What's up, Frightful? How you doing, buddy? I don't know about EA Sports. Can I do type of sample type dot name dot name? Let's take a look at sample type. Okay, doesn't like that. I'll just hard code it. Screw it. Name. Wait. Property type name equals string. Operator kinds. What's this complaining about? Is equals dot toString. Good. And I need rule definition. Public string. Property name. Gonna need that. Property name equals name of sample type dot name. There we go. All right, now we need to build the rule. Now we need to use this information to build the instance of rule. And we're going to do that in just a minute. I'm going to go on pause for just a second, and I'll be right back. Okay. Now, to build a rule, to instantiate a rule, we need to know the type of the subject and the type of the property being scanned. I'm not going to create a rule builder just yet. What? Now, here's at. Here's send. Copilot. Add file to chat. Collect diagnostics. Explain last command. Generate docs. Generate this. Open logs, walkthrough, chat feedback. Use reflection and to get an instance of type that matches the type names referenced in the rule definition. All right, so it calls out to the subject. Our subject type is my ruledef.subjectTypeName, and if that comes back as null, we're gonna vomit on my sweater already. Type not found. And I want to do my rule dot subject type property type operand type equals that. Save this. want to instantiate a rule base. And we need a rule expression. So we've got that bit so far. We can use these type arguments to find the correct constructor method to create the rule we need to create. We're going to need some more stuff, though. Rule base. All right. Make generic type var rule ctor equals that. Now we need an expression. Create the rule expression that will be used by the rule. Because I want to take a look at rule base. It needs the rule expression. What do you look like? Operator kind. First, we resolve operator, what's it called? Operator kind name to an instance of the operator kinds enum. Make it so. All right. Next, create the rule expression instance. Boop. And now, finally, come on, Rob, it's comment time. We can build our rule base instance. Make it so. Now that we have our rule instance, let's run it. What is rule instance? And cast it as an instance of our rule type. Because we can't just have it as an object, otherwise that gets really goofy. Yeah, whatever. Rule-based constructor not found. rule CTOR. And rule instance. Look at that. Cool. I wonder. I'm a little curious. So if the property name sampletype.name, what if I went to sampletype.something else? Sampletype. IDK. Account balance. I believe that's a decimal. Comparison constant. Okay. Need to convert the comparison constant to the correct type. All right. And I'll zap this. Do that. I believe that's the right order. Let's find out. And I'll just create a couple of these. Dynamic test sample equals new sample. Let's say 3. Tom. Dynamic test sample 2. I'll just leave it as 1 test, bait time now, and now. 5. Sally. Sally's rich. And bool dynamic result 1. Rule instance dot evaluate. It is that how I'm evaluating up here? No, I want to execute. Rule instance. Oh, nonsense, it doesn't. Oh, so it doesn't. what's this nonsense? Of course not. So we're going to need var test value. That's fine. In our CTOR, I need a private read-only property info prop to test. All right. Now, prop to test equals rule applies to dot get property name, throw no exception. If this evaluates to null, we need to bail immediately because somebody goofed. All right, property name not found on type, rule applies to. Cool. Another validation we want to do at this point is if prop to test dot get type is not type of V, go. And that's sort of a misleading exception message here. So the rule definition property type name specifies but the actual property is of type that. Save. Now we got some grumps. We can't do that. Equals var test prop value is that if test prop value is null, we're just going to return false. Out you go. Test value equals convert the reflected test prop value to the correct type for the rule. Now let's zap that out. Do that. And I'm gonna say V. What's this complaining about? 2V. I think we'll just do it this way. Get rid of those silly things. There. Save that. We've got some bugs out in program 1. What are you complaining about? So I don't want to execute against the account balance. I want to execute against the instance of the subject of the rule. Bool, dynamic result 2. Let's try that. I'm going to pause, and when I come back, we're going to run this and find out what I screwed up. I'll be right back. All right, main screen turn on. I am back. I will save. Now, we know the hard-coded stuff works. So let's not worry about those. Block comment. Boop. All right. Here, we'll just drop the breakpoint right here. Okay. Time for the moment of truth. And I want to run my test app console. Our deaf cat here. No idea what she sounds like. Is confused because a new person's up, so she thinks she can yell for more food. And I already filled both bowls this morning, or one of the bowls this morning. All right, so we've got our rule definition. Cool. These are all strings. I should probably change comparison constant to an object. Oh, it is. I'm just expressing it as a string here. So, subject type, bounce. Oh, it doesn't like that. Type, sample type not found. Okay. So it doesn't like that. We're gonna need to do something a little bit different here. So represents type declarations. Yeah. Get type. And instead of name of sample type, what if I do sample type dot let's just do name of sample type. Keep that there like it was. Save. As Copilot. Control C. This line failed at runtime. Do we need to do an assembly scan on the loaded app domain to obtain types that are not declared in the current assembly? If the type you're trying to get is not in the current assembly, you may need to scan the loaded assemblies in the current app domain. Okay, so get type from app domain. That's what I'm going to have to declare. So this, I'm just going to copy this. And I'm going to paste it down here. And instead of public, we'll just erase that. There we go. Get type from app domain. This we're going to need to bring in system.reflection. Get assemblies. I feel like this could be shrunk down because there's hundreds of assemblies that get loaded into memory into the app domain. So yeah, not that worried. Okay. Get type from app domain. Now I'm going to replace this with a call to get type from app domain. My ruledef dot subject type. Name. And let's do the exact same thing here. Get type from app domain. Because what's happening there is the get type that we had before, I think only looks at the absolute current most local assembly and doesn't look at the other assemblies that have been loaded into the process via reference or imports or what have you. Like all of these things up here, like the using test app types, that tells the compiler that it should know about the types that are in that reference namespace or assembly. Now get type just operates on obviously the current or the nearest assembly to that method. It doesn't know how to look outside of itself necessarily. So what we have to do is scan all of these projects that get compiled into DLLs and then loaded into memory as assemblies, and scan all of those until we find a match for our get type. And there's some things we can do to make this a little bit less cumbersome. Like I could add some code here to figure out, you know, what the base namespace is. And if the assembly name starts with that base namespace and I have like a consistent naming convention and all that stuff, it'd be fine. But for this purpose, I'm not going to mess with this here. That's an optimization that I would probably add later if I felt like it was needed. So save, get type from app domain. Yeah. We're doing all the things. Let's retest. So we've got our breakpoint here. There's no sense breaking there. It's just setting up that variable. And we'll go to test app console, right click, debug, start new instance. And it's going to pause on that get type from app domain. And let's step over. And it exploded. Type, sample type not found. You stink. All right. That isn't going to work for me either. I think I probably have to use a more qualified type name. And let's ask. So the assembly scan method didn't work. I'm guessing it's because I'm looking for type by its class name only and not its full name. Without an instance of that type, how should I go about obtaining the reflected full type name? Namespace and assembly information. You can iterate through all the loaded assemblies, find a match. Here's how you can modify, blah, 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 blah. For each assembly, iterate through all the types, check if the type name matches the provided class name, return the full type if found. Okay, so get type from app domain. You can see that stuff here. God, I love Copilot. Get, haha, yes. A little bit of linky dinky do. Let's take a peek here. Pull you over here. Oh, yeah. That's... When I was down here looking... Yeah. When I was looking through here, I was like, I know I've done this in the past, and I've injected some link to make it really, really sweet. So I need to go assembly.getTypes. Assembly dot get types dot first or default t dot name equals type name, and we'll try that. Type local variable type, and let's make it null. Just to get those compiler warnings out of the way. There we go. Get type from app domain, string type name, do the things. And let's try it again. Debug, start new instance. And we're fooling around and we're finding out. Okay, we are at the line. Let's step over. Hey, what's subject type? Oh yeah, we got it. Our operand type, what are you? System exception, type decimal not found. Okay. Fine. Let's go to sample type. Count balance is a decimal. Fine. You know what we're going to do? This is silly. Type of decimal dot name. Save. Let's try that. And is building. And let's try the breakpoint. Where are you, Mr. Breakpoint? Let's just run that.
I didn't bring it downhill last time.
Right, so maybe they're not.
Okay, we're on the breakpoint.
Maybe they didn't go by yet.
I guess.
We've got our subject type.
They're doing it at
Groovy.
But
Now,
No idea.
fair enough.
the ruledef.property type name is decimal with a capital D. And we have stepped over. Fantastic. Now, we now have a generic type for our rule type. And rule base, full name. Cool. Generic parameters. Yeah, whatever. All right, so we've got that. It is not null. Do we have a constructor? We do not have a constructor. So that kind of threw up. Let's make sure we've got the rest of the stuff that we need, though. So operator kind is equals. Our rule expression is a rule expression with the operator of equals. We have an evaluation strategy in there. Comparison constant. Let's make sure that's the correct value. Good. Now our rule instance, we don't have a constructor for that rule. So we got to take a closer look at what's going on there. And we're going to stop. Now, get constructor. And let's take a look at rule base. And its constructor is string, string. Type of thing. Because this is no longer a must inherit or an abstract, save that. Try it again. Now we know all that stuff worked, so great. Let's pop down here and we'll pause on that line. That was probably a sillier mistake that I could have avoided if I didn't have my head in my butt. So our rule type is this. Let's see if we can get a constructor out of there. Oh, yes, sir, we have. Fantastic. And we've got all of our stuff.
No, like, stuffed up nose or...
And system.exception, rules engine DLL, but was not handled in user code. Property type name specifies decimal, but the actual property is of type runtime property info. I goofed something up there. So, oh good, we're right inside that execution context too. So the prompt to test
And I'm gonna put some sausage in there.
is
After all,
account balance. So we got that. Property type. Duh. Another slaphead error. I don't need the type of property info. I need the prompt to tests property type. Save. Try again. All right, do we have our rule instance? Oh, we sure do. So we need the account balance to equal $10 on the subject that is passed in. So here's our dynamic test sample 1, dynamic test sample 2. Now, dynamic test sample does have an account balance of 10M, whatever that means. And sample 2 has 100,000 M, whatever the hell that is. Might be money. That might be like a glyph that turns a number into a specific type. So, dynamic result 1 returned true. Dynamic result 2 returns false. And we are all done. And we did a whole lot of work and wrote a whole lot of really exotic code that kind of borders on black magic. But I hope I did a decent explanation of what each of these lines is doing and why we're doing it. And so this afternoon when I come back, I'm going to take this stuff that we wrote this morning to create an instance of RuleBase without actually having to write the code to create a specific class that can execute that rule. I'm going to take this code and turn it into a builder method on that RuleBase class, and I'm probably going to rename some classes and do some refactoring, and then extract this and turn it into some publicly available source code that other people can use. And it's me, I'm other people, and I'm going to use it in other applications because this rule definition class, it's just a half dozen properties, each of which is a string, which means this is going to serialize to JSON beautifully. Or it could serialize into a CSV or a row in a table or whatever, a comma-separated list of strings that I could stuff into a configuration variable, whatever. And that means I won't need to hard code a lot of the rules that that my validation system is going to need. And that's pretty damn cool. So this afternoon, I'm going to make all of this goo, all of these weird incantations and invocations and summoning and construction into a hidden, or not a hidden, I'm going to hide all this ugliness behind a static method, probably on the rule class, so that you can pass in this rule definition and get back an executable rule. So that's pretty neat. That's very neat. I will see you this afternoon. Thanks for joining me. Take care of yourselves.